All right. Well, hi guys. This is our third Python workshop and unfortunately our final one. And for those of you who don't know us, I'm Suchita R.
And I'm Ryan Bascos. So, before we talk about what we covered in the last workshop, I just want to let you guys know that if you want to test out any of the Python concepts that we test now and try and integrate them with your previous knowledge from the previous workshops, make sure to go on to repl.it during this workshop too, to just kind of experiment with the different concepts we cover. No, I think that's a really good way of really making sure that the knowledge really settles into your mind. So here's what we covered in the last workshop: comments and the escape character and how they can be used to create special string characters, how to take user inputs, debugging, a really important process, collection data types, list methods, for loops, while loops, and then we finished everything off with a Kahoot. Here's what we'll cover in today's workshop. Now, it may look like there's not that many concepts we're covering, but they're really broad and complicated, so we'll fill up a similar amount of runtime. We're going to cover iterators, functions, classes, class objects, and inheritance from superclasses to child classes. So what is an iterator? So an iterator is an object that contains a set of values and returns them one at a time by iterating over them, or repeatedly looking at the iterator's next item. So an iterator is created from an iterable using the iter function. You can see an example of that in the example below. An iterable is just a data type from which an iterator can be created. And an iterable data type includes collection data, lists, tuples, dictionaries, sets, and strings. And in a string, each character in the string is its own individual item. Calling the function next and putting the iterator inside of the parentheses there will return the next item in the iterator. However, if you've reached the last item in the iterator and call next again, it will raise the error stop iteration. As you can see in the example, iter with the example placed in as the list into the function will create an iterator from the example. And every time next is called on example iter, whether it's in a print statement or not, example iter always goes to its next item and next returns that instead. So it doesn't matter if the next statement is inside a print statement or just in the code. It will always move the iterator to its next item. And using the next function a fifth time stops the program because it erases the stop iteration error. Here's how iterators are used in loops. Iterators are actually used in for loops. When a for loop iterates over an iterable, like a list, the for loop will actually create an invisible iterator object from the iterable and use the next method for every iteration, which is every time the loop fully runs. So as you can see, the for loop that loops for every item in the example list is the same as creating an iterator and running next 4 times, as in for every item in the iterable.
So a function is a block of code that takes parameters, which are the ones inside the parentheses, and runs only when it's called. It is used to generalize large and complex code into much smaller and simpler containers to decrease the complexity of it. Oh, sorry about that. It can return data as well as pass on data to another function. Um, and you can call it, like I said before, by using def, which is a keyword, the function name, parentheses, and the parameters, if there are any, inside of the parentheses, a colon, and the block of code that you want to be executed when you call the function. And to execute the function, you just need to call the function name with parentheses, of course, and any added parameters. So parameters and arguments. When a function is called, the information passed into its parameters are arguments. Parameters are declared in the function's declaration statement. So the argument is substituted for the parameter, which is basically alien name. So mark alien name. The function aliens takes mark as an argument and passes it through the function as the parameter alien name. So these are just different names for each other. But when you have alien name here, that means that you need a parameter, at least one parameter. So if you just forgot about Mark and you just did alien name, then it would produce an error because the function needs a parameter in order to run. So just like a quick overview again, what is declared in the parentheses when creating the function, otherwise known as alien name, is a parameter and takes the value of what is passed through the parentheses when called, which is the argument, which is also known as mark. And just for like a quick overview, the local variable is the parameter, which means that is only accessible within the function and not outside of it. And the variables created in the earlier workshop were global variables. So that means that you can access them outside of the code. So if you called alien name outside of the function, it would not recognize it because it is a local variable. You would have to make it global. And yeah, these are the examples of simple functions which I went over.
And just to let you guys know, a global variable is just any variable that's declared outside of a function and outside of a class, because that variable could then be accessed from within any function and within any class.
So for an example, in the first one, it says def my function first name, last name, and then print first name and last name. So when you call my function, inside of the parentheses, you have to give two arguments. Otherwise, the code will not run. It will just produce an error. So we gave two strings, Michael and Jackson. And then that goes to the function, and that takes it as first name and last name. See, Michael is first name and Jackson is last name. So when it prints it out in the function, it'll print out as Michael Jackson. And when you call the function, it will print that out. Another example of this is deaf student kids. And when you call students, why are there three arguments when you only have one parameter? Well, that's because you put an apostrophe, sorry about that, an apostrophe because you don't know how many arguments you want. So you can use it like we talked about in tuples and lists. You can like take the second index of how many parameters that you inputted and print it out. So you don't exactly really need to know that. These are just like extra examples, but functions can be used in classes and other forms of object-oriented programming. And don't worry, we'll talk about that in the next few slides as well. So here's some of the function's key statements that you might need to use when you're having like a simple function. So first up, we have return statement, which is basically to output or return a value from a function. And they return values and terminate the function when it's called. So here we have return 10 times x. So when you call the function, which is named return values, and you input 2, it takes that as x, and then it times 10 by 2. So you get 20. And the second one, you give it 4 when you call it, and so that gives 40, and so on. So you can do that an unlimited amount of times as long as you have the return statement. Return can print it out because like we said, it just returns the value of 20 or 40 or 80 to that function. So when you call it, it is automatically stored. So you can actually put that in a variable and then print the variable out differently. But we just did an automatic print statement. And there's the next thing, function recursion, which is a function can call itself like an infinite amount of times. You have to be careful about that though, because if you keep on calling the function and you don't have a stop statement, it's basically like a for loop and it can keep going on infinitely, and then it can take up a lot of memory and storage data. So in this example, we have the function recursion and it takes in k. So we have that and it prints out recursion results and it gives k. If k is greater than 0, then we have another variable and then it does all of that and it prints out the results. So here we have result equals k plus recursion k minus 1. So when we do recursion, it's basically calling the function with k minus 1. So for example, we gave 9, right? So it goes if k is greater than 0, and it is. So it goes through that, and then it has result equals k plus recursion k minus 1. And basically it calls recursion at 8, and it just keeps on going. So when recursion is called at 8, then it'll loop again and do the same thing. That's why we have 1, 3, 6, 10. And when it becomes 0, the result is equal to 0, and it returns the result. So when we print out, when we return the result, it returns it to recursion 9 when we call it.
All right, now let's talk about generators. If you need to work with a very large data set, you should consider using a generator. It's a special type of function that uses yield instead of return. Unlike return, yield does not terminate the function, which means that you can use yield multiple times in a single iteration. When a generator yields several values, the values are put into a lazy iterator. So what does that mean? A lazy iterator is used the same way as a normal one, but it only returns values when it is asked to, rather than saving its entire set of values in memory. So what it'll do is it calculates the value based on saved data from the function, rather than storing every single result from the function. Now, don't worry if that sounds kind of confusing, because generators are a complex function to be used for complex projects. Like if you're working with like a machine learning data set and you're training your model. But that's besides the point. Here you can see an example, simple gen. It's a generator function that has a local variable number and sets it to 0. And while that number is less than 2020, the function will yield a number or return it, and it will increase the number by 1. Now, since it's yielding multiple values, it'll store every single num that is produced from the while loop into an iterator. But since this is a generator function, it will put that data into a lazy iterator instead of a normal iterator. So as you can see, you can use a for loop on that result of the function. You see, when you put simple gen as the thing that the for loop is looping over, you're actually looping over the iterator, because that's what the function returns. And then for every item in that iterator, it will print the item that it's on right now. And as you can see, it's printed every single number right before 2020. And you can even use a generator to create an iterator with infinite values. But you'll need to stop your program from running, because it will literally keep going on forever at a very fast speed. So I got this code from realpython.com when I was looking up Python generators myself for this project. And as you can see, this, this function, infinite sequence, will continuously create a bigger and bigger iterator, because that while loop, while true, is always true, because the Boolean true never changes. So the function will continue to yield num and increase num by 1 infinitely. And as a result, the lazy iterator that is produced from that function that is passed into that for loop actually has infinite digits. And when you actually run this program, if you copy and paste it into Replit, or if you just copy it from the screen here, it will print this super long stream of numbers, as you can see on the right, extremely quickly. And the only way to stop it is to manually click stop on it. Or if you know how to do it on your IDE, you can do a keyboard interrupt. I think you do that with Control C. I think that's the button for that.